Hello, welcome to Marsh Mathematics, and in this video I'm going to be looking at implicit differentiation. Okay, so in this first example the information we need to remember is in red, okay, and I'm just going to highlight it in green. Okay, so if we've got a function of y, okay, anything like 3y squared, y cubed, anything like, how do we differentiate it with respect to x? So that's what this means. We need to differentiate something, a function of y, a term, anything, okay, with respect to x. So what we're going to use is this is a way of writing the chain rule. So what this first part means is that we differentiate it with respect to y first and then times it by dy by dx. The reason this works is that these two dy's cancel each other, you see, and so these two are equivalent. Alright, so let's have a look at a nice easy example. So we wanted to find out dy by dx on a circle. Okay, we've got a circle, we want to find out the gradient of a tangent at any point on that circle. Alright, well actually this circle should be there. Alright, so we differentiate with respect to x. Okay, that's what that means. So we do it by term, so this becomes 2x. Now how do we differentiate y squared? Well, we differentiate it with respect to y. That's what this first part means. Then we get 2y. But then we must multiply it by dy by dx. So this here is the chain rule. And we just differentiate 25, which is just 0. Then we just rearrange this, take the 2x to the other side, cancel the 2's, and we get minus x over y. So this gives us the tangent at any point on that circle. So at the point 3, 4, the gradient of the tangent would be minus 3 over 4. Okay, so this point here, 3, 4, the tangent would be negative there. Now let's have a look at this more difficult example. This is sort of maybe an exam standard, and we have a function here, we have an equation, and the reason it's called implicit differentiation, because if we have y equals something, that's when y is explicit. Okay, it's explicitly given in y is explicitly given in terms of x, but the reason it's called implicit is because y is not equal to something, it's implied, it's implicit. Okay, y is not, the equation is not given as y equals. Okay, y is given implicitly. Alright, so how do we differentiate it? Well, we differentiate y with respect to y and we get 1, but then we've got to remember what's the rule. We just do times by dy by dx. So that's how we get that first term. The second term we differentiate with respect to y, okay, which is 3y squared, and then we must remember to times by dy by dx. We differentiate this term here, and we know that the derivative of sine is cos, so that's 2 cos x. Then what we do, we just simplify, factorize, get dy by dx by itself, divide by both sides, rearrange it, and we get a expression on equation for dy by dx. It says show that as a turning point at this point. We substitute these two values in, which we should know that cos pi over 2 is equal to 0. So that means that dy by dx is 0, therefore it has a turning point at pi over 2, 1. Okay, so there is a typical example of how you would use implicit differentiation. Now here is a more typical exam question, okay, because the thing about this is that if you look here, we've got an xy term. Now this is very typical because they get you to use the product rule. So this question involves using the product rule and also implicit differentiation. It's 2 for the price of 1, if you like. Right, it's the way of testing you on two things at the same time. So I've done this, I've done a solution here, but I've explained how I've done the product bit here. So let's just go through it now. We have to differentiate it term by term with respect to x. So y squared with respect to x is going to be 2y. Now we must remember to times it by dy by dx because it's a y function of y. Now this term here I've explained over here. We'll have to make u 3 because it's a product, okay? Make u 3x and y vy. So if we differentiate this term with respect to x, we get 3 du by dx is 3. When we differentiate v with respect to x, we're going to use implicit differentiation, so you get 1 when we differentiate y, but because it's y we must differentiate times it by dy by dx. So they're all your terms there, and so we substitute it into the product rule, okay, and I've shown you that one there, and that's how we've used the product rule and combined with implicit differentiation. Okay, now so it's best to do this bit on the side separately. Okay, so it's the product rule with implicit differentiation, then we can just write, that's why I put a bracket around it here to show that I've done it separately. Now the x cube's okay, which is 3x squared, and the 25 goes to 0. Now the thing is, we have to factorize this, and so you get the dy by dx, and we factorize it with 2y plus 3x in the bracket. Take the other two terms to the other side of the equation. This is a standard practice to do this, okay? And then divide by this term, and we get there an equation for dy by dx. Now sometimes they ask you, prove that there's a turning point at something like 1 minus 1, and you'd know that because when you put that in, you would get minus 3, and you would get 1 minus 1 there, and you get 0 on the top. Okay, so you need to look at the top. So to find out where dy by dx is equal to 0, if they're asking about turning points, it's the top part that must equal 0. Okay, the bottom cannot equal 0 because then it'd be infinity. So that's the sort of thing they get you to form an expression, then they'll start asking you where turning points are, and so the top part of that quotient or that fraction must be equal to 0. Okay.